I think there are things that are very visible. Of course, ChatGPT was very visible, but there are other things that Google pioneered and came up first. For example, when we introduced structured outputs, there was JSON mode for OpenAI models, but you couldn't define like a strong JSON schema for the outputs. And structured outputs came first with Gemini, for example, or other things like, let's say, well, there's been a bit of buzz around, for example, Notebook LM, which is one of our products and experiments where you have those AI hosts that discuss about the documents you gave it and create a podcast, etc. So there are some cool innovations coming up as well, and not necessarily as visible as this, first mover advantage of something like ChatGPT. But I kind of like this challenger place in a sense that you get to, okay, we need to do better. So for example, you've seen that we progressively climb all the leaderboards and benchmarks to be always at the top, if not the first model everywhere in every benchmarks. So it's interesting to see this competition between the actual players in the field.
It's interesting to see when you see the titles of some of your posts, what you've written, like advanced RAG techniques. That's something I expect, but things you never dared to ask about LLMs. What was that about? What was the thing you never dared to ask about LLMs?
Yeah, the thing is, so there's all the buzz, around LLMs, but there are things like, along the way, as I was learning, so I did some AI before LLMs, etc. But when LLMs came up, ChatGPT, Gemini, etc., there are some topics that are kind of glossed over, or we don't really talk much about those topics. So for example, okay, we're using tokens, but why are we using tokens? Why not words or letters? Or why LLMs are not good at math without any help? So there were several questions I asked myself, I wondered about, and I was like, well, I'm not reading much about this in articles or seeing anything at conferences about those aspects. So I was like, I need to dig deeper to better understand. So it's not so much about understanding the math, like how the matrix calculations actually work, but really figuring out the little things that make LLMs work and the way I can better understand why they work in some aspects or scenarios and not in others, basically to take the best out of the LLMs. So I was very curious to, learn and write about those things and share about those things that I found along the way in my learning journey.
And I think that's general good advice. I started my blog in 2006 as a scratch pad. I just learned something and I wrote it down. And basically I didn't know something, so I forced myself to learn it and wrote down the learnings in my blog and basically learn in public. And that became a big success. Back then I made money with it. Forget about that one. Everybody has an ad blocker now. But it was really interesting to see how that actually worked out. Now, Mette, you have a great talk about pitfalls of LLMs. So pre and post processing is required with LLMs. Why?
Yeah. So the great thing about LLMs is that to get an output from LLM, you just make a single API call. It can't be any easier, right? But then people think that it's so easy. But usually, that's for Hello World kind of applications. But usually, if you need to do something more complicated, you need to pre-process your data, and then you need to make the call, and then once you get it back, you need to actually post-process it. So it's never just a single API call. For example, if you need to ground your LLM, you need to probably set something like a RAG that Guillaume will talk about probably. So a RAG pipeline. So that means that you need to take your documents, you need to chunk them, you need to put them in a vector store. So there's a lot of things that needs to happen beforehand. And then once you have that, then you make the call, then you get the result back. And then again, the result you get can be, by default, it can be any format. So if you want a certain format, you need to make sure that there's a structured output. And then if it's JSON, then you need to get the JSON. And up until recently, it wasn't great JSON. So sometimes you would get JSON, sometimes it wouldn't be quite JSON. So you need to put some handling around that. Nowadays, it's better. So most latest models, they actually give you JSON. So stuff like that, right? So it's never just a single API call. So that's why I tell people you need to either think about these things and implement them yourself, or you need to rely on a framework like LangChain, or LangChain is the most popular one, but then there's Llama Index, there's a semantic kernel from Microsoft, stuff like that, so that you can kind of offload some of this stuff to the frameworks.
It's interesting. When I worked at Microsoft, I worked at Yahoo when JSON came out, and Douglas Crockford worked with me, and I worked with Enterprise before that as well, and it had like XML and XML schemas and SOAP and all the horrible things we don't want to know about any longer. And the first thing I'm like, so yeah, where's the schema and how can I validate the JSON? And he's like, I don't want that. It's not going to happen. It's just basically, it's a very easy data format. But now it seems that we actually, we need that in that environment as well. So Guillaume, like when it comes to this pre and post processing, it seems like the LLM is never enough. It has to be an AI stack around it that helps you to actually request the right format, validate that it is actually in a format that's good for you, and then convert it to something else. So what do you think is the most important part of that, the pre or the post?
Oh, pre or post? Well, I think somehow the post situation has improved, especially with the structured outputs, because now models, or most models, are able to really follow and mandatorily follow the actual JSON schema that's been requested. So maybe it's the what you put in that needs to be maybe pre-processed or double-checked, or asking clarifying questions. Or I remember doing an app that was taking. So I was a multimodal kind of application where you would give a picture, and the app would generate hashtags for your Instagram posts. And the thing was that when you gave or you let the LLM free to come up with an explanation why it comes with this or this hashtag, the hashtags that were generated were more creative. Whereas when I was using structured outputs, I would get less creative hashtags. And so I did things in two steps. First, be free to generate prose and suggest hashtags. And then a second step where I extract hashtags from the first request. And the output was much better because I had more creative tags, yet they were very structured because I just had a list of hashtags in the end. So sometimes you have to, experiment a little bit to figure out what works best in output and outputs. And sometimes even the way you define the schema in outputs also helps the LLM better frame its answer. So both are important, but the input is important as well.
Like I should also add, like I find it a little bit funny how the things that's been around for a while, they come up as new. Like for example, now in Python you can define like pydantic classes. Like so they're basically just classes that you define, and then you pass that to the LLM, and then when you get the response back, you get basically these strongly typed classes, and it's being like presented as like this new thing. But I'm like, in Java world we had like Hibernate with databases where it did all this like strongly typed stuff, automatically. So it's basically the same thing, but in a different context, and yeah.
It's a bit like when we went from
like,
JavaScript to TypeScript, because we needed types on top of the thing to scale to like thousands of lines of code and actually help with intelligence and like the IDEs giving you the different things. Now, when you said like creating hashtags, and another big thing that I always is a bit of my bugbear is when people do alternative text for images and say like it's good enough if the machine writes something there. But as a non-sighted user, I might get absolute nonsense. A great example that's just doing the rounds is like that people asking all these different chat systems to create a picture of an empty room with at least no elephant in there, and all of them actually put an elephant in there and then claim that they haven't put an elephant in there. So that's the new strawberry problem that we had with other things before. Now, Mette, in your talk, the other thing is that the next bit is the problem with LLMs is that they hallucinate. I mean, I always thought like hallucinate sounded like a bad excuse, like we don't know why it does it, so we just tell it hallucinates. But what are LLM hallucinations, and what can work around them?
Well, basically, the LLM tells you stuff that's not true, but it does it in such a convincing kind of way. And that's the problem with hallucinations is like, for example, just the other day I did a demo and I asked the LLM, can you generate the first 50 prime numbers? And then it just went on and explained like how it's going to generate and what math formula it's going to use. So it looked really convincing, but in the end the result was wrong, especially with math, like they're not that great. But in Gemini 2.0, you can actually enable code execution. It's a tool where the LLM actually generates Python code and then it runs it. So with that, if you need to do a calculation like prime numbers, for example, then you get basically more accurate results. So that's one thing you can do to make things better. But the other thing you can do is basically you need to ground the data, ground the responses with some data. You can either ground it with things like Google search, for example, or you can ground it with your own data. So if you use a RAG kind of pipeline, you can ingest your data, and then when the user asks a question, you find the relevant documents, and then you feed that to the LLM, so the LLM uses that kind of like it's like a subset of data that it uses when it answers. So we are basically constricting the LLM to a small data set. That way it can give us more accurate and more directed answers. So that's what you can do with hallucinations, grounding your responses basically. That means you need to use something like on Google Cloud there's a Vertex AI search where you can ingest your own website data, or you can ingest your own PDFs, things like that, and then you pass that as a tool to the LLM, and then LLM will use that instead of Google search, for example. So that's how you would ground with your own private data. And there's so many different ways of grounding. Again, like there's Llama Index, for example. You can use Llama Index to ground. There's LangChain has different ways of grounding. So like I don't think there's one way, and there's no one standard yet. So it depends where you're running, which cloud, and what kind of technologies you're using. And then with that, you will use one grounding technology, basically, depending on what kind of grounding you want to do.
Now, Guillaume, the other problem that LLMs have is that they're costly to train and they're costly to weigh. So they're actually outdated public data. So I remember the first ChatGPT version was from 2011. So when you asked it about new CSS features from last month, it had no idea how to do that. How can we work around that issue that you work with stale data in an LLM?
Yeah, so typically, since we mentioned web searches and RAG, those two aspects are definitely the best way to solve that problem, in the sense that when you do a web search, it's going to search for live information, the latest information that's been indexed by search engines. But when you work on your own data, of course, especially when it's private information, customer data, etc., LLMs haven't been trained on that information, so they can only hallucinate. It's not possible that they give proper answers out of that, or they could just say I don't know if prompted correctly. So when you use RAG, actually the information that the LLM will generate ultimately is as up to date as the data you gave it in the first place through the RAG search results that you put in the prompt of the LLM. So if your data is up to date in your vector database, etc., then the responses will be up to date from the LLM. So that's really the two ways to get past outdated data and get live information.
So you can also provide LLM access to any API, basically. For example, let's say you want to learn about weather information from today. I mean, one easy way of doing that is to run with Google search, and Google search will get the weather information. But if you want to,
look out the window, or
or another one is that you have a web API, and then you basically provide that again as a tool to the LLM and say, look, there's this weather API available to you, and you can call it with these parameters, and this is kind of so you basically provide a function with some description of like what the function is supposed to do, and then you pass that to the LLM, and then LLM, when you ask about the weather, it figures out that okay, now someone is asking me about weather, so can you call this function that you told me it exists? And then your application will call the function, get the result, feed it to the LLM. then LLM will respond back saying, okay, the weather in London is rainy and 10 degrees or whatever, something like that. So that's another way of like feeding your LLM with like any kind of data really coming from any API that's accessible by the LLM.
And that becomes really immediate. I remember Gemini yesterday announcing that it can actually do live video reading of your mobile phone. So you can actually ask Gemini what's happening on your phone at the moment, which sounds to me kind of scary because I'm like, did it share the whole thing? Where did it go? So, but the immediacy is there. One thing you have in your slides here is that LLM inputs can get expensive. What do you mean by that, and how can you work around that?
The latest models, they have this long context. I don't remember the exact number because it always increases. It was like 1 million tokens or something, but now it's 2 million. And what that enables you to do is you can basically send like long text, like or like you can send your whole repo, for example, in one request, or you can send like a bunch of videos at once to the LLM and ask LLM, can you analyze this? And it will do that, which is great because you're giving a lot of context to the LLM. But at the same time, like these things, they cost money, right? Like because the bigger the context, the more tokens you're going to use. So if you're going to keep sending the same stuff over, let's say there's a video of a movie or something like that, and you want to ask a bunch of questions about it. If you keep sending the same video over and over, you're going to keep paying over and over, right? So that's why it can get expensive. But there are things that you can do to help, and these are basically good old software engineering principles. So what you can do is, for example, on Gemini, there's something called context caching. And the idea of context caching is basically you create a cache, and then you save things that you're going to reuse in your prompts, like videos or PDFs or your whole GitHub repo or whatever. So you save it there, and then you use a cache data when you ask questions. That way, you're not only sending it once, and then you can ask multiple questions to it, and it will be much cheaper that way. So that's one way of getting the expenses down. Another one is like if you keep sending prompts one after another, like like let's say you need to do processing of like 100 things, and you can just do the naive thing and just send 100 requests one after another. That's going to be expensive because first of all, you're sending 100 requests like as if they're separate requests, and secondly, it will be expensive because you're going to do it sequentially. Again, you can use the good old software engineering principles, and you can do batch generation, what's called batch generation. This is, again, another API from Gemini, where you basically just say, okay, these are 100 images I want you to process, for example, and then you just do a batch call. So you send the whole call, 100 calls at once, and then Gemini will do all the calls and then populate the results somewhere. And then when it's done, you go and check the results, right? This, again, makes sense because you're parallelizing all the calls, but also it's cheaper. So instead of doing, like, I don't remember the exact number again, but compared to regular calls, it's much cheaper to do it a batch kind of call. So you need to think about these things. Like, don't just do the default thing, the easy thing that just make a call and get the result back, but think about like how much it costs and what kind of features I have available, like batch generation or context caching, to make it a little bit cheaper for you.
It's the same with like Gen AI. When you think about it, like, okay, let's generate 5 pictures for me. Let's generate a video for me. And halfway through, you realize it's hallucinating. It's not giving me the thing that I want. And you want to press Control-C, but you can't because it's actually just plowing away doing the thing. And I think there's a bit, there's a concern about like not only using up your tokens, which can get expensive, but also just in terms of memory consumption and energy consumption that is unnecessary. So batch processing, cleaning up before you actually send things there. There's a lot of tools right now, for example, cropping up that allows you to upload videos and give you like a 5-hour video and give you like